For those who just walked in, and for the sake of those, we're going to watch this on the recording since I'm now starting about, looks like 8:47. I'm starting 17 minutes late. That there, actually 45 minutes late from our official starting time. So that there. So anybody who's late comes in now, they're really late because we're really late starting. Okay, I'm finishing today. After today, I'm not having any more lectures. So. You know, this Thursday, this Friday, Monday. Now, next week, the plan is that I'm going to go through and tell you what the questions are going to be on the final right now. I want you to study over them over the weekend, and if you want to meet next week and have me review some of the questions in more detail, then either message me through Facebook or WhatsApp or call me or whatever, or email me and let me know, and I will schedule a meeting this time next week. That there. Otherwise, we will assume that next week we won't meet unless there's a request from any of the students that there. And if there is a request, I will post it on Facebook that there will be a meeting to discuss what problems are there. So if you make a request, tell me what problems you want me to go over in the meeting that there. So the idea is to give you time to review. Now, your final exam, as I look at this right here, is May 20th. So you got one of the early ones. So your May, and what is going on here? I have the ugliest M this morning. That's there, but your final exam is 20 May. Is it 23rd? Oh, hold on here. This is microcontroller, this is microcontroller, correct? Yeah. I don't know why I got May 20th here, but give me a second here to, no. Give me a second. They sent out a schedule, then they sent out a revised schedule, and maybe the revised schedule has the 23rd. Give me just a second here to the hotspot. There. All right, give me a second here. I need to turn on my hotspot right there. And where is it? Oh, there's my hotspot. The internet never works clean in this room, so it's easier to use a hotspot right there. And it should come up and ask me for a password. Message dog 2919. All right, don't tell me you're having trouble connecting. The two of you are right next to each other. Right there. Android, unless there's another Android AP. No one else has a hotspot turned on, do they? Well, in the meantime, let me just look at final exam. This is from last May, so that's not it. Okay, all right, let's not worry about it. So it's whenever your final exam is set, it's set, okay? I'm not going to spend 10 minutes looking at trying to find the final exam schedule. I know that there's one that what I had listed was 20 May on 2016. You're saying it's 23 May? Yeah, what time? 9 a.m. Oh, that's too dark early, right? For a final exam. Well, it's all right because I don't have to think that time. I just got to show up. I know they came up with a new procedure, but when I typed the final exam, I think I had the preliminary list, so I got the wrong date on that there. So they change things on a regular basis. They schedule them way out. They schedule them 3 months in advance, and then they start changing the schedule. Of course, they want the final exams 2 months in advance. That there. So, which is all right. So we're talking 23 May then, 9 a.m. Which means that my final exam is going to be wrong. When you get it, it's going to have the wrong date and time on it. That there, which is fine, because if you're sitting in the room taking the final exam, you already know the date and time. So seeing the wrong one on the final exam doesn't hurt you any. Okay, let's get in here what we're talking about. There are 5 questions. Answer all 5 right there. There is, some of you are used to some final exams where you got 5 questions and you pick 4 of the questions that they're high qual because of the way that they're doing their student assessment evaluations. The report that I have to write at the end of the semester saying how well people did requires that I test you on all 5 course outcomes. So as a result, I have to have all 5 questions answered right there. So that there. Okay. Question number 1, that there, and I'll be quite honest, these questions, some of these are right exactly the same as you had in the microprocessor class. There's some overlap between the courses, and question 1 is an overlap course, and it deals with things that there, and I'm just going to call it micro C basics. And I'm not going to write down what all the questions are, but let me just kind of give what they are. This is being recorded, so you can. Their first question, there's A, B, C, D, E. There's 5 parts of it. They're each worth about 4 points. That there, and they're all short answer essay type questions. There's no problem solving, no program writing, and they cover topics like what are the differences between a microprocessor and a microcontroller. Why don't we use floating point math with a microcontroller? What are the serial protocols? All the various, all these were covered through the lectures, but not necessarily can I point to a particular lecture for each, for the whole problem. But it's kind of general information questions right there. So one of the points there, I'll tell you what, difference between microcontroller and microprocessors, the memory addressing. What's the crossbar used for? The serial, what are the serial port protocols? And the floating point question. Why don't we use floating point? So those are the 5 parts. I just told you the questions right there. So if you don't know the answers to those, I'm sorry. I specifically told you what those questions are right there. But it's kind of a general information question, not there. So, and one of the points that I should make is that as you take this test, don't leave any answer blank. The amount of credit you get for a blank answer is 0 points. If you answer the question and it's wrong, you might still get 0 points, but you might get lucky and get, out of 4 points, you might get 1 or 2, because I think that you have a general idea of what that there. You just don't remember the right answer right there. So don't, there's no penalty for wrong answers right there. The only thing I should point out is that I don't think any research has been done in Malaysia, but in the U.S. there's been a lot of research done on exam taking, and about 75 to 80% of the time when someone marks through an answer that was their first answer, and they go back and change the answer, usually they mark through the right answer and put a wrong answer down. So usually you should go with your first guess that there as you're going through that there. Unless you really know that you really remember the right answer, but if you're going back and making a second guess, chances are the second guess is wrong and the first guess is right. That there. And that's just general rules on test taking. If you're guessing, go with your first guess. That there. So problem 2 deals with clocks right there. Again, that's very similar to the microprocessor course question right there. It may even be the same question reused right there from when you took the microprocessor test at there. But why do you use certain clocks at there? Now that's the first part of the question right there. So problem 2, part 1A is clocks. Now I don't ask you how, I'm not asking you to write any code on how to pick a particular clock, how to set up the clock, that there. But why do you use one clock versus another? Why do we need an external clock versus an internal clock? Those types of questions. They're general questions. And what I'm shooting for is that you understand the concept of, if you go with a very high-speed clock, you're going to decrease battery life. You know, the faster the clock, the quicker the battery, you know, the higher the power consumption, the faster your battery goes dead. That's why when you're using, you know, a lot of these cell phones, like the Galaxy S series, the Galaxy S series, the S3, the S4, S5, S6, the S7's out now. They use, you know, what they call octa-core processors. Octa-core processors are, it's got 4 high-speed processors for when you're really cranking, you're watching a video of what you're playing a game, and you need very high performance. And they got 4 very low-speed processors for when you're doing everyday things. And the reason is that the low-speed processors are used when power consumption is, you know, to reduce power consumption, and your needs aren't so great. But if you're watching a movie and it's high definition, and you're really pushing that processor, then you use the high-speed processor. But watch your battery life drop quick right there. So those kinds of questions where we're looking at that there is the speed difference changes that there. And then again, I talk a lot about the 20% variance on the internal clock. So if you need any type of accuracy in the clock, and one of which is serial communications, that's a big hint right there, is if you're going to do serial communications, you have to use an external clock right there. So, that there. Okay, part B, even though we never did it, I never got it working, is the LCD interface. Basically what I'm looking for is you know how to connect it up. We did that part, but it didn't work. And the reason it didn't work is we didn't have 5 volts available to us. But I basically will give you an LCD, and then you have to show me how you would connect it up to the processor. And that goes back to that website right there. I can't show that website because I've got internet connected, right? No, I never got the internet connected, did I? The internet never did connect because it never did ask me for the password. Right there. And it still isn't going to ask for the password. Let's try connecting to the local internet and see if that works. That should give me a page where I can put in the information. So it's connecting. I think my computer's, I didn't shut it off last night, and as a result, it, don't you just love that our interconnect? In order to log in, I have to bypass security on my computer right there because the I can remember the login. Oh, and I don't remember that either. Right there. Well, I've got this is supposed to automatically log me in. Oh, there we go. Yeah, I don't know where I got that from. Yeah, I guess it worked, okay. And where Okay. And it says I'm connected to the internet, but it seems to be extremely slow. Okay, well, I gave you this website it's that page there. You don't need to know the programming, but you need to know the wiring from that page right there. It was part of that one lab that we did. And, well, evidently the internet is working because it says that, but it's extremely slow. Okay, well, we won't argue with it there. But it's the LCD wiring right there. I'll just put it like that. I'm not, quite honestly, just telling you what the question's about is probably more than adequate because it's going to come from that website right there. And it doesn't need, and you also need to know the pins coming out of the LCD display. Obviously, there's VSS, VDD, VE, RS, RWE, D0 through D7. You need to know what those pins are and how they would wire into the microcontroller right there. So that was question 2. Question 3 is got 4 parts, and it all deals with question 3. All deals with the analog to digital converter right there. You need to know what an SAR converter is. I spent some time talking about how it relates to a binary search. But you need to know why we can have multiple analog inputs in with only one ADC. In other words, you have to understand the concept of using the flexible pin muxing. Actually, to be honest, I give you the block diagram of the ADC, and there's lots of hints in that drawing to answer the questions right there. So the question is, how can we have 16 analog inputs when we only have one ADC? And then if you look at the drawing, you'll see on it something called multiple pin muxing. Right there. There's a big hint on what the answer is going to be, is that we use a mux to decide which one of the analog that there. So, and then there's 2 parts there and I gave you, I pointed out the equation in the slides where if I've got, V reference, and this is an example, is equal to 3.3 volts, and VN equals 2.5 volts, ADC equals what? In other words, what will you read from a 12-bit or a 10-bit or an 8-bit ADC right there? And I go the other way too. I give you a value that there, in other words, 12 bits, I've got 4E2, that's a 12-bit value. V reference is equal to 3.3 volts. 3.3 volts. VN equals what? Right there. So it's that type of question right there. So problem 3 deals with nothing but the analog digital control. It comes all from that one set of slides right there. And I did a demo on the ADC in this class, as I recall, right? Last week, yeah. So I showed how that worked and how that there. But there again, there's no programming in problems 1 through 3. You do not need that there. And so you can get 60% on the final exam without knowing anything about writing any code. That there. So everyone complains that they don't. That in order to pass this course, you know how to write code. You get 60% and you haven't written one line of code, right there. So, and since everyone's got all the freebie points on the final on the phase test, you're at 70%. You got 10 points already, and you got 60% in the final exam. You've already passed the course and got a C. So you can actually, you can get a C in this course and not write any code out there. I need to change that. Okay. Problem 4 is a little bit more difficult. I spent a little bit of time on it, but basically it comes from a website, and I don't know if I posted in this class. I will post it. It's actually an app note. Let me just put a note on here, problem 4, and you can actually search for it right there. Problem 4 is a motor control problem. right there. And I believe I had a lecture where I talked about that. If not, if you look for App Note 191 in the Silicon website, and I think I posted that on Facebook. If not, someone will let me know and I will post it. And it comes out of that, the first part of that. And what it basically is what is PWM, pulse width modulation? I know I've talked about that, pulse width modulation. We didn't do a lab. I did a demo on it, as I recall. After I brought the motors in, I showed how they worked. I didn't go into great detail, but explain the type of, you control the motor. I give you that there, but I really suggest that you read this, App Note 191, right there. Now let me bring that up. I know that I have it on this computer. It's in the desktop, right there. There it is, App Note 191, right there. And this is a note from the Silicon Labs right there, and if it's not on Facebook, you can just go to the Silicon website, just put in AN 191, and you can find this document right there. But what I do is right there is what I'm going to tell you right there is, you need to understand how this works right there, that particular drawing. And it's all in this text right there. Right there. So, and then they show DC motor with reversing. They go through DC reversing hazard. They go through all kinds of things. The only thing that I'm going to hold you responsible for, and I didn't really cover it in great detail, is the first part of this on just basic DC. So it's this circuit here. So what I suggest is you read example 1 from App Note 191 right there. And there's some questions from that right there. And again, I don't think I covered it in great detail during the semester. I think I might have missed this lecture right there. But that question's on there. I suggest, and that's why we're having this session. I'm telling you right now that what you need to do is find this document. If it's not on Facebook, ask me. I'll put it on Facebook. Right there, I would do it right now, except for I don't think I have internet. Let me try, see. Oh, yeah. Yeah, this is the document, the website right there. And let me actually start off here. Let me just see if my Facebook is working right there. While I'm lecturing, I may as well put this stuff up, right? Otherwise, I'll forget it, right? Right there. Okay, first thing, that's the LCD right there. So that website's there for you to look at. And then the next thing is AN 191. Add. I thought there was add photo, video, poll, that file. Okay, that's one I want. Choose right there. And we said that was on the desktop, and I found it right away because it's right there at 191. Okay. All right. So those two documents are there. So problem 4 comes all out of this. First part comes all out of that there, yeah. And then, and again, the second one is kind of a repeat that there. Actually, the next one actually is an Arduino example that there. I give you an Arduino circuit, and you have to explain to me how it works. But it's very similar to this right here. The only thing is this one has the H bridge, so there is a problem on the H bridge, and I do remember covering that in class. That there. Problem 4. I should point out, is one of those problems that I don't necessarily expect everyone to get because I didn't cover it very well in class. And I have a tendency that and this is a habit that comes out of the U.S., to ask 1 or 2 questions on the final exam that were not covered in class just to see whether or not your brain can figure it out. There. I know that that's not common here, there. But one of the things, and I talked about it with another class, is that when you look at education, my view of education is what's more important than you memorizing everything I tell you and you regurgitate or throw it back out onto the exam table that's there. In other words, you eat it and then you put it on the exam, put it on the exam form sheet when you're done, but you haven't processed it. You haven't analyzed it there. And the only way to know whether or not people have analyzed anything and understand it is you ask them something you didn't tell them. That's closely related to what you did tell them to see whether they can draw the lines between the two, between the unknown information that I'm asking for and what you already know. So when you look at problem 4, I'm telling you the first part of it. It's out of App Note 191. You read that and you've got the answer for the first half of problem 4. When you look at the second half of problem 4, I didn't tell you that information. It's a similar type problem, yeah, but it's using an Arduino, and I'm asking you how it works, and you have the H-bridge, and you got to explain to me, that there. But on H-bridge, I covered briefly in class. I didn't spend a lot of time, but that's used for reversing motors right there. So it's one of those cases where I'm not going to tell you the answer to problem 4B, but I'm just going to tell you there's a question there that you don't know the answer for because I didn't tell it to you. But and I just see how you do right there. As I said earlier, you're going to pass the course if you just regurgitate everything I told you in problems 1 through 3. And now I gave you half of problem 4, so now you get a problem that I didn't give you the information for. That's what separates the A students from the C and the B students right there, is that ability to go from what you've been told to something you haven't been told right there. Problem 5 is the toughest problem. Problem 5 is basically the design problem. Think like, it's not the, I'll tell you right off the bat, it's not the stoplight. It's something different. I think I may have used it as an example when I covered it, but it's a finite state machine problem where you go into a state, you wait for something to happen, you go into the next state, you wait for, a timeout and the problem starts out with write a short program that will control X, Y, Z under the following conditions, and then I specify what the various states are and how long you stay in them or when do you move to the next state right there. And again, you can think of everything from, dishwashers, washing machines, water heaters, assembly lines. I mean, anything like that there, some type of control application. So it's fairly well specified what each step is right there. So you've done everything in this problem. I mean, everything in the stoplight, if you did with the turn signals where you looked at the switches and things like that, you've done everything that's in this problem, in the stoplight project right there. But this is a different project. So again, I'm looking for you to take what you learned from the stoplight, and if you actually learn how to do the stoplight and learn the process, then you can do this problem. If your lab partner did most of the work and you just sat there and looked over it, you're not going to be able to do this problem right there. So problem 5 is by far the more difficult problem, most difficult problem that there. You've got 2 hours for the final. My guess is this problem will probably take 20 minutes if you knew how to do it well. The rest of the test you can probably do in 30 minutes if you know the answers. I mean, they're all fairly quick out there. Problem 5 will probably take you a good 20 to 30 minutes by itself. It actually should be worth more than the 20 points it is. I could actually, if it wasn't for filling out the report, on the CLOs, I could actually just give problem 5 as the final exam and walk away. And I had an instructor do that to us one time. He had a 5-question final, and he looked at it, sat at the desk when he was giving the final, and said, just do problem 4, that's it. Right there. And trust me, problem 4 took 2 hours. Right there. It took 2 hours to do that problem 4. Right there. You filled the full. And problem 5 is a little bit that way. I don't necessarily expect anybody to finish it perfectly. And remember that I'm looking for, if you understand the process and you understand, don't get hung up on syntax. Do not worry about your syntax. I will not take points off if you leave a semicolon off. That there. I don't, syntax, I don't care about syntax because programming languages change. That there. So syntax changes. What I'm looking for is you understand the concept of how to use a select case. Right there. Whether the syntax is correct or not, I don't worry. But you understand how you would transition from one state to the other, that you put the if then else statements in there. If the syntax isn't right, but you still have the basic concept. If this is true, then we go to this state. Otherwise, we go to that state. And you can write the code in BASIC for all I care. You can write in Pascal, any other language you happen to know. Although I think nobody knows any language, but a rudimentary C is about the only thing that you know. But but the point is that I don't care about the language and the syntax as much as you understand how the program is supposed to work. Right there. But problem 5 is that one, and that's one that I'm not going to redo for you next week. That there, because it would take too long to explain the entire project like that. But it's very much, if you, I can't say it enough, if you understood the stoplight program, in all parts of the stoplight program, including, having the turn lanes, if there's a car in the right turn lane, you go into the right turn lane state. If there's not a car, you skip that state right there. If you understood that concept, that there, and if you understood the lecture when I talked about, for example, if I had, a tank that I'm filling with water, that it's going to, the pump is going to be on until a sensor shuts it, tells it it's full. I think I talked about that in a washing machine. I think that there. If you understood that type of logic, that there, then this problem is a straightforward problem, and you should be able to answer it. I've given similar problems in the previous courses. The first semester I taught this class, I had 5 problems, select one. Nobody did this problem. They all skipped that problem. That there. Last semester is do 5 problems. That there. Some people still skipped it. That there. So it is that there. But don't skip it. Try it. Write something down, because if you skip it and you don't do it at all, I just write -20 on your exam and you get no credit for it. If you started and you're going nowhere, you might get 4 or 5 points, but it's better than nothing, right? And if you go through it and you start doing it, you might realize that as you're going through and putting the steps down, that you actually get pretty close. You may end up with 15 points out of 20. You didn't finish it, but that there. So I encourage you to at least try the problem. That there. Don't just skip it right there, because if you skip it, then you get nothing for it. That there. So that, in a nutshell, is our final exam. The only thing on the final exam that I don't think I covered in great detail, and if you want, we'll meet next week and I'll go through it, is App Note 191. That there. I did not necessarily cover that in great detail. And the H-bridge, I can come back. The H-bridge I won't go into great detail, but App Note 191 I didn't really get into very much. But we can meet next week and go through that there. So I think I'm going to kind of wrap it up here. We started late, so we're going to finish early, right? That's a rule of thumb. You always start late and finish early. That there. But we will not be meeting for lab this week. That there. Obviously, next week we wouldn't meet at all because that Monday Friday group, there would be no meeting that there. But we're finished with the labs. That there. The course project was the end of the lab. That there. I most likely will not be on campus tomorrow, but if someone needs to see me between now and the final exam, I'm not going out of town during the revision week or anything like that. I'm going to be around, but I'm probably going to be playing hooky. You ever hear the term playing hooky? Playing hooky means not showing up to work when you're supposed to be there. Like some of you do during classes. If someone skips a class without an MC, we call that in the U.S. playing hooky. That there. I don't know what hooky is, but it's just basically skipping class. That there. Playing hooky is usually comes from kids that are supposed to be going to school, and they get diverted at the park on their way to school, and they spend all day at the park and forget to show up to class. Actually, I had a brother that did that for 3 months in a row before he got caught. He didn't show up to class for like 3 months. My parents didn't do a very good job keeping track of us kids out there. So he was like maybe 10 years old, just decided he didn't want to go to school anymore. So instead of going to school he just go to the, on the way to school, he'd just turn over and go to the park out there. So he played hooky a lot out there. Finally got caught, and he got in trouble, had to go back to school, out there. But I'll probably next week, between now and the final, I'll probably be in and out. So if you want to see me, you've got questions, just text me, email me, fax me. Fax machines don't exist anymore. I remember when fax machines first came out, we thought they were the greatest thing on the planet. You could actually send documents across the country via the phone line. We thought that was great out there. Nowadays with email and video conferencing and all that stuff, Skypes are obsolete now there. But just how to get a hold of me out there. So except for days like today, I have my phone at home. So but that's it. It's been a pleasure. I will see everyone. If I don't see you before, I'll see you at the final exam out there. Remember, any lab report that is still open out there, including the course project, I need it by next Wednesday right there. Not necessarily Thursday, but next Wednesday I need those so that I've got time to get them in the system before people go away for revision week out there. That way, if I get them by next Wednesday, I can get them in the system by next Wednesday. I'll send everyone an email. Everything's in. If you're missing something, you still got a day or two to get it to me before the end of the semester. I think I can still stick grades in even after during revision week, but the whole idea is that I hate to put zeros in there for something that you did and you forgot. Now, if you didn't do a lab, then I'm sorry, I'm not going to open the lab up and have you redo it. Give you time to do it. But if you did the work and somehow it got lost in my knapsack or I put it in the box in my motorcycle and it disappeared out of that there. My cats that like to live in the attic stole it and ate it that there. Whatever happens that there. We used to say the dog ate my homework that there. I guess now they talk about the monkey stealing the homework or whatever in the dorms that there. But whichever that there. So